Okay, I'd like to introduce Luke, VK3, UKW, who's done some great work interfacing and automating the WIA broadcast into the repeater, etc. So without more ado, Luke, hand it to you, and I'll turn this off.
Okay, good evening, everybody. Hope everybody can hear me fine. And yeah, slides working. Good. So as most people here are probably aware, there is, well, actually, that's going to be in the introduction. So I'm just going to go to the agenda. We're going to have an intro. I'm going to talk about the problem that we're solving. I'm going to talk about the solution design. Going to talk about the implementation. That's going to be the biggest part. And then I've got a few bonus slides, depending on how we're going for time. About me, I've been licensed and a club member since 2017. I think I got my advanced license in 2019. I do SSB contesting, portable ops, digital and computer controlled nodes, so done a fair amount of FD8, all that little thing. Also digital SSTV, tactical comms, so I do, I'm with Vysen to do emergency communications, and also electronics and making. And a few of those things came together in this project. So about the WIA news broadcast, it's a weekly news broadcast from the WIA. There's a new one every Sunday, and it gets transmitted every Sunday and Wednesday. There's also a couple of other days where people rebroadcast it, but Sunday and Wednesday are the main days. And that gets rebroadcast by clubs and other interested parties around the country, both on repeaters, and there's also a few HF broadcasts. The EMDRC rebroadcast of that has been going on for a very long time, definitely since before my time. And the very simple problem statement is, how do we do this rebroadcast? Every week we get an audio file on the internet, usually Friday night is when the new broadcast for that Sunday comes out. So all you have to do is download the audio file, send it out on the air, easy job done. And how you do that is left up to, as an exercise to the implementer. Now, there's obviously a few challenges with that. One is interference. Ideally, you'd want to put the audio in directly at the repeater and block the normal repeater uplink. The same thing about interference goes for the nets after the broadcast. So there's always callback and net after the broadcast. And of course, that's a very nice target for people who want to interfere with the repeater operation, because they'll have an audience then. Then the audio quality, of course, first up the analog path between the player and the radio, and then also the audio levels, both on our side and also on the WIA audio file side, because they don't do a whole lot of compression or normalization. The way the broadcast is done is people send in their audio bytes. Everybody records their own audio bytes on their laptop, with on a phone, whatever. There's no standardization of background noise or anything, so the levels vary quite a bit. And then you've also got the timeout timer challenge on the repeater, which I'm gonna go into a little bit more in detail. On the old system, when we had an analog repeater controller, was one of the very popular controllers from a little US company. I didn't write down the model. On that, we had multiple uplink frequencies. So we had both UHF and VHF frequency, the UHF frequency. I think because we're no longer using it, that was a little bit of a secret squirrel thing, but I can say it now. The UHF frequency was actually on a commercial frequency. So in theory, safe from interference. And then also the radio broadcast was injected via that special UHF uplink frequency. The repeater also had the configuration where it had a timer clock in it, and you could set settings based on a timer. And so it had a setting where every Sunday at 10 a.m. when the broadcast starts, it blocked the uplink, the regular uplink for regular users. And so only the broadcast could go out, and it also overrode the timeout timer. So you didn't have a timeout timer on the repeater, or you didn't, maybe the way it was implemented is that there just wasn't a timeout timer configured on that UHF uplink input. And yeah, that was managed by Ralph VK3LL and Damian VK3KQ. And they definitely did their time with keeping that system working. Ralph has got a few good war stories that I think he's told in his presentation about the new repeater. That was a couple months ago. So definitely recommend listening back to that one. And definitely, if you've missed it, we've got the video of that on our YouTube channel, which you can check out. Now, for the new system, we decided to upgrade our technology and go for a Yaesu System Fusion repeater from Yaesu, DR1X or something or other. And what that repeater is, if you look into it, is two Yaesu mobile radios hooked up back to back with a little controller managing it. And it's not very feature rich. And it's got fun things like some things in it you can only configure on the front panel. You can't configure it remotely, even though it's a digital repeater with digital control and internet connection. But some things they just haven't bothered implementing in the remote control protocol. So yeah. If you want to do it, you have to go to the repeater site, which is a problem specifically for us because getting access to the repeater site is a bit of an issue. Yeah, you have to do it there. It's got only one uplink frequency. Like I said, it's two radios back to back. One of them, one receiver, one transmitter, and that receiver only got one frequency. It does have a microphone connector, so you can use it as a base station and can talk into the microphone, but we haven't really looked into that. The way it's controlled is that Ralph has built a little board that uses a mobile phone uplink to get commands and twiddle the few knobs that you can twiddle on the repeater controller. But the main thing that can do is turn it on and off. We cannot block any uplinks, and we cannot override the timeout timer. That is the big issue. So the transmission timeout timer on a normal, pretty much every radio has that. It means you key up, and after a minute or two or three, the transmitter just turns off until you release the PTT and let the transmitter cool down. It prevents a single transmission from keeping the repeater open, even though it blocks the repeater completely, which is something in a single frequency system you can't avoid anyway. One of the main motivations is to prevent the transmitter from burning up, and obviously to keep it from locking up the frequency in a fault case. So if something has gone wrong inside the transmitter itself and it's just transmitting dead air, that is something that you don't want, and that is something that At least if you're a commercial operation, you're going to get a call from the ACMA pretty quickly. So you should have your timeout timer that detects if you're only transmitting dead air or if something else is wrong, and then just turns the transmitter off. Now, on that Yaesu digital repeater, that can't be turned off. The maximum timeout timer is 3 minutes. You can't get it any further than that. We had it set configured to 2.5 minutes, and so we're going to have to work around that. Now, what you can't get around is that if you don't want to get locked out by the timeout timer, you have to pause the broadcast. So you can only broadcast 2.5 or 3 minutes at a time, and then you have to wait for the repeater to open up again. With this Yaesu repeater, that's over 2 seconds that you have to pause for it to reset. And there is an existing solution that there's a group in, pretty sure it's South Australia, where they have Yaesu System Fusion Network with a whole bunch of users. And they also do the broadcast there over the Yaesu C4FM network and frequencies. And their existing solution is that they just chop up the broadcast into, I think, 1 minute and 45 sequences. And so that's just a hard break where potentially, or not just potentially, but definitely at least some of the interrupts are going to be in the middle of somebody saying a word. And that is obviously quite disruptive. Now, can we do that a little bit cleverer? So the way to do this in a more clever way is to make this adaptive and pause the broadcast when there are breaks between words. So you have to process the audio file. You have to find those periods of silence, breaks between words, breaks between sentences, potentially breaks between sections in the broadcast, and just insert your pauses there. Now, what you could do is you could add a pause after every word. That's obviously going to still be pretty disruptive. You definitely don't want to have a ka-chunk after every word. So you find those 2 to 3 minute intervals, and you insert pauses there. And then that is going to be, that's the idea anyway, much less disruptive to your listeners and to the broadcast, and have the minimum amount of ka-chunking that is just required to make the whole thing work. Now, we've got a couple of components to that. First up, the software. You need a whole bunch of different components to that. The first one is the download script that downloads the broadcast every Friday or Saturday from the WIA website. Then you've got to find those pauses inside the audio. Then you've got to have to do the actual broadcast, the reproduction with the broadcast timing when you actually want to do the broadcast, and pauses and transmitter control. And then the other thing that I haven't really mentioned is that we do have our System Fusion node, a full node set up. What that does is you can link it to other rooms. So you can have, like in your regular talk group setup that you have on all digital radio networks, you can have any station connected, any station or any room connected into our system. And we've got a radio for that in here where that's running on, and then that gets transmitted to the repeater and repeated on the repeater, and it overrides the analog mode. So obviously you don't want somebody breaking in while you're doing your broadcast, so ideally you want to block that while you're doing the newscast. And then with the hardware, we just took the stuff we had laying around. So a small computer, Raspberry Pi, is probably the first thing anyone would go for. A VHF radio that we had in the storeroom, IC281H, nice and battle tested, I would say. I think that is a radio probably from the 90s or the early 2000s. And then you also need an audio interface to get your broadcast from the computer into the radio, and that's where I did a little bit of home brewing and used a modded CM108 sound card, and I'll explain what that is all about in a minute. Now, how do we implement the software for this? I didn't implement anything. I just took the Swiss pocket knife of audio-video processing, which is a tool called FFmpeg. That's an open source tool. It processes audio, it processes videos, it processes all file types known to man, and it does anything you want to it. Whether you want to extract frames, splice videos together, rotate your video upside down, do picture-in-picture, split audio, insert audio, anything you want, you can do. It's a command line tool, and so the trick to using FFmpeg is not the question of can you do it and how you do it, but how you construct the processing graph in an arcane incantation of the FFmpeg command line. Luckily for what we want to do, it's pretty simple. We just need to run the silence detect filter, and what that does is just goes through the audio file, and you tell it, I want to find all periods in the audio of, say, half a second long that has under, say, minus 30 decibels of audio level. So if you have a half a second where the audio level is minus 30 dB throughout that whole period, then you can be pretty sure that that's where nobody is speaking, where there's a pause between words, pause between sentence. And of course, you want to be still above the background, any background noise. Ideally, you want your background noise level to be at minus 40 or minus 50 dB. And so with your 30 dB threshold, you should be above that. And so you should be able to find all your silences in your audio. And then we don't want all the silences. Like I said at the start, you don't want to ka-chunk after every word or after every syllable. So you go through this whole sequence and you just pick one every 2 to 230 minutes for extra fidelity to make it sound even nicer. You use a window of 30 seconds where you just pick the longest one because then the longest silence in that period is ideally a break between a sentence or a break between a paragraph where it's going to be even less noticeable that you've got that ka-chunk in there. And then once you've found one, you slide the window forward and look at the next 2 to 2.5 minutes and find the next one. And then you go through the whole file, and then you've got your audio file with those pauses every 2 to 2.5 minutes that you can then broadcast with those pauses in it. Then you just want to play that back. So at the broadcast time, you play that audio file, and whenever you come to one of those silence times, you just pause, release the PTT, and like I said before, we have to do that for 2 seconds to make sure that the repeater actually resets, and then we just continue playing. As an extra, we've got everybody who listens to the broadcast would know that before the broadcast, 5 minutes before the broadcast, we've got an announcement that says, you're listening to VK3 REC, please stand by for the broadcast to commence in 5 minutes. And then after the broadcast, there's an announcement that goes, thanks for listening. Please stay on the line for the callbacks and that. So we add that in. And that's all we need for the software. Now, like I said, I put it on a Raspberry Pi. I happen to have a box with a Raspberry Pi and a display, and you can see a little RTL SDR dongle down here for sonde hunting. So I already had that, so I just used that. I've actually got a UI there that shows you, if you look at it while it's playing, what the current play time is, what the next pause that's upcoming is, and so on, which currently we're not using because we're operating it remotely. And then the next little thing that we need is we need to have a PTT control, and that's the thing that I homebrewed. Now what I implemented in the software here is both the ICOM CIV protocol, so the regular ICOM serial control protocol, and then also the CM108 GPIO. So the ICOM CIV protocol, you can use that with any modern ICOM rig that you just connect via USB, or of course the older ones via serial. There was some code out there that somebody had made for their own for amplifier control. That's Gordon Anderson KG7YU, and I asked him if I can use it, and he said, go ahead. So that's integrated in my code. And then the next one is the CM108 GPIO, and that's going to be what I'm going to be talking about next, I think. No, we got one other thing, blocking the fusion node. So what we have here on a computer in the back there is the WiresX node software. So that's the WiresX software from Yaesu connected to Yaesu FDM900 digital radio. And that has got a web server plugin. And with that web server plugin, you can just use a web request to lock and unlock the transmission or the repeater functionality. So 5 minutes before the broadcast, you lock it, and 50 minutes after the broadcast, you unlock it, and that way you don't get any interference from anybody using the WiresX node. We had some well-meaning participants who were linking our node to the room that had the WA broadcast on digital, but we didn't want the digital broadcast, so we had to add that to just lock them out and be able to do our analog broadcast. Now the CM108 interface. CM108 is a popular, well, older now. There's probably not that many new products made with it, but you can get a lot of them for $15 on AliExpress with as a fully implemented USB sound card. And the special thing with that chip is that it has GPIO pins. So just pins connected to the chip that you can drive with a high level or a low level, and that you can also use as input pins. And the great thing is that they are implemented, they have software control using the USB HID, that's Human Interface Device protocol. And that means you can interact with that without any special drivers. And if you've got a USB sound card, and if you've also got GPIO pins that you can program yourself, then you have everything that you need to create a full radio computer interface to control transmission and audio or data into the radio and out of the radio. Now, what's on that old IC218? We've got the ICOM 2 via data interface, which has got 3 pins, 1 ground pin, and then we've got the series for data operations, so it talks about TNC. But over here, we've got the 2.5 millimeter check with ground, PTT, and data input. Data input is where you put the audio in, and then the PTT, when you short that PTT to the ground, then you get your key down just like I think probably everybody who's done amplifier control or digital radio has probably seen that before, that you've got a active low pin on your radio, on your accessory connector, and your radio interface has to pull that low in order to make the radio transmit. Now, in order to implement that with the GPIO, you need a signal inversion, because on your chip, you probably don't have direct current sinking capability. So you've got a signal on your chip that goes high. That's here where the signal comes in from your chip. And then you've got your connection to your transceiver where you want to pull your PTT low. And so you need a little bipolar transistor and diode setup. So you've got your transistor up there, and when you set the GPIO signal high, then that turns on the transistor and means that you get basically a connection between the collector and the emitter of your transistor, and that means that you've got ground and PTT connected, and that turns the radio on. And then this is what it looks like. There's a better picture. So you've got your microphone check here and your speaker check for your regular audio. There's the USB. That's what you plug into the computer. And then you've got a little bit of a mess over here. And what that is that this here is where the left audio channel of your audio output goes. And we've removed the left audio channel. And instead, we're putting out the PTT signal there. And you've got your diode and your transistor and your resistor here. And out here on the chip connected, you've got your output signal. And that way, you've got that connected. This is the YD0NXX version, where they've set up obviously a connection to a radio with a signal cable, and that's going to have your plug for your radio at the end with like a DIN plug or whatever. But I thought, why do I need to do all of this weird soldering and put all this stuff in there when instead I can leave these audio jacks in place as they are, and I just steal one of the audio channels for my PTT signal. So that's what I did, and then we get an end result, and the end result is that we've got a similar process as the old system, where the broadcast goes out every Sunday and every Wednesday. The audio quality sometimes gets compliments, sometimes gets complaints, which is mainly variability in the levels of the source file. And there is another thing, another problem that I had with the levels, which I've solved, which I'm gonna go into, I think probably as part of the bonus slides. But for now, this is probably where the any questions should go. Yep, Lionel?
You mentioned how you had software to detect when it drops below 30 decibels. What happens if the input file was reasonably constant in volume and never dropped below 30 decibels in the 2.5 minutes?
Then you don't have a voice broadcast. If you've got a voice broadcast, so the 30 decibels is 30 decibels below the peak level, right? So you've got me talking, and every time I stop talking, obviously the audio level goes down. Even if you've got background noise, background music, whatever, if I want to create an audio file that has audible, my audible voice, me audibly talking, then whenever I stop talking, the audio level has to go down. Otherwise, yeah, of course you can have, if you have very loud background noise, or if you have something else weird going on, then maybe that's not, but in practice, any spoken broadcast is going to have those breaks in it, in pauses between words. Does that make sense?
Yeah.
You described how you get the breaks. Do you have any idea of how many actual breaks you would be performing over the length of a typical WIA broadcast?
Typical broadcast is 30 minutes. You need a break about every 3 minutes, so about a little bit over 10.
But in practice, is that what happens? Or
yes. Yes, because I've got this. Like I said, the way I process is that I insert a break every between 2.5 to 3 minutes, and it always happens. Now there is a fallback if I don't find an acceptable pause in that, then it goes and looks further back. But in practice, it should work out to that 10, maybe if it's really, if it really gets compressed, then maybe 15 breaks.
Right. Okay.
And I don't think that most people who are listening to the broadcast, I don't think it's very noticeable. Maybe somebody who does listen to the broadcast every Sunday or Wednesday has got some feedback on that.
One thing I'm not sure if it was made clear earlier is that this now happens all hands-free, all automatically. In years gone by, there's been some very dedicated members who've had to give up a Wednesday and a Sunday to actually make it happen using older processes. Jack being one of them. And now Luke's built this so that it's totally hands-free.
Maybe I missed something, but okay, you get your break, and you put a pause in the audio, and how do you generate the PTT release from that?
Oh, but that's because the player has the audio player also does the PTT control.
It has a
so
you're using that GPIO
yes
signal, so you basically tell it. Yeah, kind of like Vox, I suppose.
You could use Vox if you have data Vox on the radio.
But you tell it when to turn off.
I tell the radio when to transmit and when to stop transmitting. Yeah.
So what you sort of have you got a visual representation of the audio, and you just like click and put two markers on and off?
The computer does it. Friend computer.
Okay.
So the way this is implemented is that it's the same way. So do you know FT8? All right. So there is a number of digital computer controlled radio modes. And those digital radio controlled radio modes, they control the radio completely. So on a full remote control for a radio also has things like it controls the VFO frequency. So what band and frequency the radio is on, it can control the transmit power. There's a couple of popular programs for that. One of them is called Hamlib. One of them is called Rig Control. And they basically give you a full remote control for your radio, which you can use on a computer that you've got directly plugged into the radio, or that you can also use remotely. So you can set it up so that your physical amateur radio at home becomes essentially an internet radio that you can control from wherever you have an internet connection. that is something that goes back a long way. So like I said, right now, what you do is all recent new radios since the last maybe 10 years, they come with a USB connection. So you just, you've got a USB cable that you plug into your radio, that you plug into your computer, and then what you get is you get both a sound card that's inside the radio that is now connected to your computer, and you also get a serial command channel where you can send text commands to the radio and where the radio sends status information back to you. And so essentially you just type into the control channel, turn the radio on now, and then the radio starts transmitting. And whatever you send in via the audio channel is what gets transmitted. And then you type in, turn the radio off, and the radio turns off. And of course, with a computer, you can automate that so that instead of you clicking a button that says transmit now, the computer does it, or a program in the computer does it.
I guess what I'm getting at is you've got the audio file. That audio file's got breaks in it.
Yep.
And it's just an audio file, but somewhere you run the program that then inserts the turn on and turn off. And does that generate a new file?
I've got a separate file for that. Yes. Right. So that's
what I was getting at.
Yeah. Right. Yeah. Sorry for starting at the first grade there. But so that let's go back to, there we go. So that FFmpeg silence detect filter, that creates a text file of the detected silences with the start and duration. And I do a little bit of extra post-processing for that to create a structured file that has all of that in it. And then that creates essentially the control file for the broadcast. And that control file is a sequence of audio files, just the file name in there, and then also all the silences that I want to insert into that file. And so my player goes through that file from top to bottom, says this playback the first file with any pauses in it, and then it also has an extra configuration that says after this one wait for 5 minutes, and with that one I get the preamble that says broadcast starts in 5 minutes. Then obviously you want a 5-minute break. And it goes through that and puts that out on the air.
Is this working? Yes.
Yep.
We're talking about a Yaesu radio system, and yet you're talking about CIV, which is proprietary ICOM.
Yes.
So how does that work?
Because it's all working over analog repeater. It's all working over an analog repeater. The repeater that we have at our repeater site in Olinda, that's the Yaesu equipment. What we have here back in the back room there is an analog VHF ICOM radio. And I control that analog radio, and that transmits to the repeater as just a regular.
You're not controlling the
user.
Yaesu at all, you're controlling the audio source.
That's right.
Okay.
That's because we can't really control. The repeater controller is not built for remote control.
Yep. Okay.
It's got a few. It's got essentially the settings for the Yaesu System Fusion that you can configure remotely, but apart from that, it doesn't really have what you'd call remote control.
Okay.
Oh, audio spectrum with breaks to illustrate. Yeah. I am going to write an article for the bulletin about this, and then I'm going to have things like that in there with a more detailed explanation.
So Luke, you mentioned you've got some bonus slides.
I do have some bonus slides.
I think everyone would love to see that.
Yes. So, we've got time. So the potential problems that you have if you send analog audio into a radio is firstly, the thing that everybody who runs 100 watts or more into FD8 to get their digital DX you get RF into the computer, because the RF comes back if you have an unbalanced transmission line, and if you don't have just the right chokes and so on, then you get some common mode current back into your radio, and then it goes back into your computer, and then your USB resets, and you do not get FD8 today. And then the other issue is ground loop audio interference. If you've got issues with your ground levels, or if you've just got some general electrical interference that bleeds into your audio, then you get interference there. And one of the things that we definitely had with the setup here with that IC281 is that there was quite a big noise level, probably due to ground loop. And because we were limited in adjusting the levels, that was quite prominent. And so I decided to build a isolation board. So here's a circuit. It's a very simple circuit. You got your input on one end and your output on the other end, and you've got two channels. On the top, you've got an audio transformer. That's a isolation transformer that's got the coils in it, especially for speech between up to your 3000 hertz that you've got typically in speech. It's optimized to transmit those frequencies and basically reject everything else. And obviously, because it's a fully isolated transformer, it also rejects any DC currents. And then at the bottom, we've got an audio coupler. So what happens in an audio coupler is that instead of having an electrical connection between your two sides of your signal, you interrupt it in the middle and use light signals to transmit your information. So you've got inside there, you've got an infrared LED, and over here you've got a diode, and all diodes are photosensitive. In this case, they've probably got a bit of a transistor. All transistors are photosensitive, but in an optocoupler, you generally have a special infrared sensitive one. And so that whenever you put enough current on this side to light up the diode, then your circuit closes on this side. It accomplishes essentially the same thing as a relay, just that instead of using magnetic coupling, you use light, and then you get your signal out there on this side, both the audio signal that's attenuated somewhat by the transformer, and then you get your inverted signal, your inverted digital signal over here, because what happens is if you send current through this, that is you put current in, or you put voltage in on this side. What happens is with the circuit here is that you're connecting your output signal on this side to ground. Now that's great, because what we have on our audio interface on the left side is we've got a GPIO pin that we can set to high or low, and what we've got on this side is we've got the PTT circuit in the radio that wants to have an active low signal. So that means the signal goes high on the left side, turns into signal goes low on the right side, so you've got your inversion there out of the box. And then you get a, you put that onto a PCB. So this is the PCB layout for that. And then you get a little board. I had these boards assembled, fabricated and assembled by our JLC PCB. So I got all of this except for the all of the little bridges here. So you've got a whole bunch of 0 ohm resistors here that I put in, both so that if I accidentally flip one of the electrical connections around, I can botch it up to make it go into the right directions if I need to cross it over or anything. And it also let me do the whole board as a single-sided board by routing traces through under the resistors, which doesn't really do anything, but it means, yeah, I didn't have to worry about the backside of the PCB. And then you get up here is the decoupling board. Down here is that USB sound card that we already seen before. And there's a bigger view. And what actually turned out to be, I think, the best part of that is that potentiometer, because that lets you adjust the level. What we could do was put in a pretty high level on the computer side to get over the noise floor that we have on the sound card or on the computer side, and then attenuated in this board down to the level that the radio wants. And then I've got a few snapshots from the development. This is, I think most people would recognize it. This is downstairs. And what I'm doing here is I've got the Raspberry Pi player up here, and I'm putting it into our IC 9700. And that's why I also needed the ICOM CIV, because the 9700 is controlled with the CIV. And in that case, not with my PTT hack here. We just did the USB connection there, and I've got that in my player. It supports it. You can select what PTT method you want. If you want another PTT method, you can implement it yourself. A few more pictures. Have I got? Yeah, there's my tower of ICOMs. Obviously, this one is owned by the club. That's not mine, but I took it home for testing. And there's my 7000, and there's my 7300. And then here, this is one of the first tests where I had this just connected directly to my laptop and was just playing it, also running the program, the whole player program that's now running on the Raspberry Pi. You can also just run it on any computer that you want because it's implemented in Python, uses the Pygame framework, and should run pretty much anywhere you can run Python. Probably not MicroPython. Yeah. Online. Sorry? Oh, another online. Frequency correction. No. Simple answer, no. Now, the corrections that you would want to do is compression. You'd want to recompress the WAA file with an intelligent algorithm that detects what the different news segments are and then runs compression on each news segment separately, because the WAA doesn't do that. They just stitch the segments together and run them that way. As for frequency correction, no. You just send in the audio. Didn't need to do any filtering. IC281 is good enough on the frequency stabilization. It's got a built-in subtone for the repeater access, which we obviously need. Yeah, it just works. There's one of the very first experiments where I've got a little speaker here just plugged onto there, and I'm just trying to see if I get anything coming out of there. Oh yeah, and this the PTT control connection was connected to a multimeter on the conductivity mode, so that whenever the PTT went down, it gave a nice loud annoying beep. And that told me that my PTT implementation was working. And that's it. All right. Any other questions? Yeah.
Luke, so what's your estimation of hours spent doing this on behalf of the club?
Sorry?
How many hours did it take you to put this together?
Oh, I haven't counted. Anywhere somewhere between 20 and 40, I think. Hours.
Tony's got another question.
You said you had issues with the different segments being different volumes, I suppose. What about using something like Audacity? Is that able to look at a segment and then maybe work out the average power? Do you know if there's an API to it, or so that you could get each segment and go, okay, I want the average power to be, I don't know, -10, and then it automatically does that for you and adjusts each segment so that the average is always, say, -10?
You can do that, but as of today, in fact, the new common license of the WA News broadcast is in effect, and it is forbidden on penalty of whatever the WA can do to you to make any modifications to the broadcast file. So I know that some people do that. That rebroadcast the news, like they add their own local news directly into the file and make some other modifications to the file based on how they think the broadcast should be. And I think the WAA noticed that and they didn't like it. So now there is a license on the broadcast that says can't do that. Now, I don't think I'd get in any trouble for adjusting the levels, but again, it's something that I want to work automatically without somebody having to manually every Friday download the file, open it in Audacity, edit the levels, save it. That's just at least half an hour of work for somebody that they'd have to do every week, and who does it if they're sick, and so on. So that's why I've got the automated system that just does everything. Yes?
Have you asked the WAA if they can do something about it?
No, but I have anybody who complained about the levels, I have told them to please complain to the WAA.
Because you think you would do it actually as you produce the file to the WAA.
Yeah.
It's not difficult for them to do. Probably no one's complaining.
Yeah, that's exactly right. It'd be easier to do it as you make the file.
So I think that for the benefit of the Zoom people, some conversation around WIA actually getting their source material right beforehand, and has anyone complained to the WIA? So I think we could run around in circles all evening with that one. But safe it to say, Luke, I think the work that you've done is absolutely brilliant to remove the labour and the human overhead from this. It's been an absolute winner and a time saver.
I'm quite happy with what I've achieved. It was a nice little project, and it is definitely useful for the club, and so I'm quite happy. There's a little bit of further work to do, which is to set up a second system as a backup, so that if power goes out at the club or anything like that, that we've got another backup that we can put into service. And I've got to write that bulletin article for Martin.
Too right. Yes, I'm very happy to get any bulletin articles. Note to everyone who's listening. And Pete, you've got your hand up, but just before I hand over to you, Peter, I would say that clearly the ball's in the court for our friends at WIA to get their source material sorted, so we don't have complaints.
There we go. Look, I think this has been an absolutely brilliant solution, but I think it is so elegant and so well thought through of a problem. These are all the issues, and at the end of the day, it's come out. And the broadcast is going out every Sunday, and thank you for the work that you're doing, just doing all the callbacks and that sort of stuff, because there's a lot of work involved in that, and it's your time, and it's a pity that we can't get more people involved in that. Anyway, that's my comment.
Appreciate the feedback. Like I said, it was a nice little project, and I'm happy that I was able to do it and provide that service for the club. And yeah, of course, that's the other thing that currently it's all me doing the callbacks and Nat after the broadcast. And so if anybody else wants to volunteer for that, I would be extremely happy. It's not a very big commitment. It's 20 minutes on a Sunday or on a Wednesday. If being net control is something that you don't know what it is, but you want to find out, then let me know, and I will definitely give you a hand with that.
So a couple of comments coming in, Luke. Well done. I think we're all in agreement that it's absolutely a winner. So
I just want to make sure nobody from the WIA is complaining. What I was saying is that people who are noticing problems with the levels on the broadcast are varying between segments. I was saying I don't have control over that. So if they would like to get that fixed, they need to complain to the WIA. Like I said before, I think the WIA is more than happy that we're broadcasting the news for them. That's what they give them out for. And they also take the callback numbers, and there is a high score table of who gets the most callbacks on their rebroadcast. We used to be pretty high up there. We aren't anymore because there's just less interest, less listeners, less callbacks on our repeater. Which, of course, if you're interested in WIA and national news, you can hear them from us. So tune in. It's every Sunday, 9:30 a.m. and every Wednesday, 8 p.m. On the repeater.
Okay, thanks, Luke. Again, excellent, brilliant work. I just ask members to show their appreciation for Luke and what he's done for the club.